I am Lalusha Noor Basha, Junior Lecturer in Physics, Government Junior College, Eddanpudi. In this class, we are going to discuss about the chapter Alternating Currents. Before start this alternating current chapter, let's see some basic information about this chapter. In previous chapters like electric charges and fields, electric potential and capacitance, and current electricity, in all these three chapters, we discussed about the certain topics based on the direct current. You see that in this chapter, there is a battery or cell, a cell is connected to a resistance or some other device, capacitor. In these type of circuits, we discuss it. In this, what is the source of the current? Here, the DC current. The source of the current is the DC. It means direct current. This is direct current. This is a direct current. So we discussed about. Now this is the chapter we are going to discuss about. That is, chapter name is Alternating Current. Chapter name is Alternating Current. Simply, it is so called AC. How it is called DC? This is also called AC. Let's see that some difference between the direct current and alternating current. If see the direct current, we can understand easily by seeing that the graph. Let's see that graph. There is x-axis and y-axis. Along the x-axis, we are taking time on x-axis. Let's suppose this is the current, the DC current is taken along y-axis. Similarly, in another graph, on x-axis, this is the y-axis. On x-axis, we are taking time. On y-axis, we are going to take AC current. Let's see the difference in this case. Whereas, for example, if this is the DC current source, let's suppose 3 amperes current is flowing here. 3 amperes current is flowing here. Throughout the time, after some time also, the current is always maintained constant. This is the 3 ampere current. The current is maintained constant throughout the time in this case. This means the magnitude remains constant. The magnitude constant. Magnitude is constant. Whereas in this, let's see the AC current. In AC current, how it will be? See the diagram here. So in this way, the current is getting changed. This is the representation of the AC current. Let's say, for example, say here the maximum current is, let's see, 3 amperes here also. Here at the first, and the time is 0 second, the current is 0. Thereafter, gradually the current is increasing, getting maximum, that is 3 amperes. After some time again, current gradually, slowly decreasing. Okay, so this is called positive pulse. This is called negative pulse. This is the one pulse. It is a one pulse is completed. During the one pulse is a combination of positive pulse and negative pulse. During the positive pulse, the current is increasing and getting decreased to 0. What about the negative? What you understand is positive pulse, negative pulse means. Suppose if this is a wire, a connecting wire, the AC current is passing in this case. The AC current is passing along through this wire. During the positive pulse, if the current flowing in this direction from left to right, during the positive pulse, then during the negative pulse, the current flows from right to left. So during the positive pulse, if the current flows from left to right, and during the negative half cycle the current flows from right to left, that is in opposite direction. What you understand here by comparing these two, here the magnitude is constant, here the magnitude is not constant. What about the direction? Here the direction of the flow of current remains constant, it is always from left to right. Okay, whereas here the direction is being changed for every positive half cycle, for every one half cycle. So in this case what we can understand, the magnitude is changing, the magnitude of AC current is continuously changing, whereas what about direction? Here the direction remains constant. The direction of DC current remains constant. Whereas here the direction keeps on changing. The direction of AC current changes for every half cycle. So this is the main difference between DC and AC. Whereas in DC magnitude remains constant, in case of AC the magnitude of AC changes continuously. Whereas direction of DC remains constant, does not change, where the direction of AC current changes for every half cycle. So you need to understand further this AC current. So we already know what is the frequency or what is the time period. The time period means, what you mean by time period we discussed about earlier classes. What do you mean by time period? The time period means the time taken to complete one oscillation or one cycle. The time taken to complete one oscillation or one cycle. So in this case, this is the one cycle. Now, how much time it will take to complete one oscillation is capital T. Time period is denoted by letter capital T. So at this point, you can represent capital T. Now, go to another cycle. This is another cycle, one half cycle, another negative half cycle. It is 2T. So, two cycles. So, in this case, in India, we are using mainly alternating current only as a source of the current. Not only India, in many countries throughout the world, the alternating current is used in many industries or home purpose also. Okay, if you buy any device, electrical device, you see the configuration of the device, they will mention that what is the voltage it is applicable, that is 220 volts to 240 voltage. If you clearly see that matter, there is a point indicated, the frequency is 50 hertz. What do you mean by this word? So did you see this word at any time? 50 is the frequency of the device is 50 hertz. What does it mean? It means that a device you bought is work under the AC current which has the frequency of 50 hertz. So in India, whereas power stations we have a different thermal power station, nuclear power station, and thermal hydroelectric power station, all these power stations then generate alternating current with a frequency of 50 hertz. Whereas in other countries they have following different frequency AC source they generate, but for example in America they generate alternating current a frequency of 60 hertz. They generate alternate current with a frequency of 60 hertz. So we are India generating the power, the alternating current with a frequency of 50 hertz. That's why all the devices we bought to work under this frequency only. So this is way means, what does it mean? It means that at 50 hertz means in 1 second it complete 50 cycles. It produces 50 cycles. This is the 1 and 2 and 3 cycles I shown here. In this way, how many cycles can produce in 1 second? 50 cycle can produce in a 1 second. And in 1 second, how many times the direction of current changes? 50 times the direction of current changes throughout the wire. In 1 second, how many times it changes? 50 times it changes the direction of current. So rapidly the direction of current changes in current flowing in wires. Okay, this is the difference between DC and AC. So next we are going to discuss about the clearly alternating current. So we are going to discuss a little bit about alternating current, the difference between AC and DC also by seeing the diagram. For example, these are the DC sources are connected, means a cell was connected to the resistance, inductor and capacitor. Whereas in this case of resistance, when the voltage battery was, for example, if it is a plug key was connected here, here also plug key was connected. Okay. So when the plug key is closed, the current flows in the direction, we can say that V is equal to IR according to Ohm's law. We know that. So when the current is means when the plug key is switched on, immediately the current goes to maximum value. Current goes to maximum value. When the switch is open, the current suddenly drops from maximum value to 0. Instantaneously happened in this case. We already know that there is no time lag between. So increment of current from 0 to maximum and maximum to 0 when the switch is on and off. Whereas in this case, in case inductor, for example, you see the inductor. In this case, inductor, when the plug key is closed, the current start to flow in the direction, current goes to 0 to maximum. In this current, when the current start to flow from 0 to maximum, as we know that according to Faraday's law and Lenz law, there is a back EMF is produced. The back EMF is electromotive force is produced in this inductor coil. This back EMF opposes the increment of the current flowing this circuit due to this battery. It opposes, according to Lenz law, it always opposes the source of the reason for the source. Means it means that the back EMF is opposing the flow of current. So what happening? The increment of current from 0 to maximum, it does not happen quickly. It takes some time because the back EMF is this opposing the increment of current. So means that there is some time difference, whereas in here instantaneously the current increase from 0 to maximum, whereas here it does not happen instantaneously. It doesn't happen quickly. It takes some time in case of inductor. Here in this also, here also, when the plug key gets closed, the current starts to flow and increasing from 0 to maximum. When it is increasing from 0 to maximum, here also there is a induced EMF is developed. It is also opposing the flow of current. In this case, in case of only resistance, the current increase from 0 to maximum instantaneously, whereas in both the cases, the current cannot be increased from 0 to maximum instantaneously. It will take some time. There is some time lag to increase from 0 to maximum. So a small time it will take. So based on that, we need to understand the term time constant. The time constant. So this is the word. What is the time constant? We need to understand this one. So why we are introducing this time constant word? Because in both the circuits, the current cannot be increased from 0 to maximum quickly and instantaneously. It takes some time. The current which are flowing in these two circuits are called, whatever the current is flowing in these circuits are called transient currents. What we call transient currents. Why so called transient current? Because the current is not increasing from 0 to maximum instantaneously. It is taking some time. So here the time constant, we are going to understand the time constant. Here when the plug key is closed, the current is increasing. I already said. How the current is changing means there is a one formula. I is equal to I naught into 1 minus e power minus r by L into T. According to this formula, the current is increasing. This is exponential function. So based on this, we can understand it will take some time to increase the maximum value. What is I naught? I naught is the maximum current. The maximum current. What is I? I is the instantaneous current. Instantaneous current. We already know R is a resistance, capital R is L is the inductance, small t is the time at instant of time. Okay, now, so based on this expression, what we can understand is the current is increasing exponentially. The current is increasing exponentially. So if T is equal to L by R in the above expression, if T is equal to L by R, substitute this T L by R value in the above expression, then I is equal to I naught into 1 minus e power minus R by L into L by R. Then I is equal to I naught into 1 minus e power minus 1. Then I is equal to I naught into 1 minus 1 by E. That is e power minus 1 can be written as 1 by E. So then I is equal to I naught into 1 minus 1 by, what is E value? We already learned in mathematics, that is 2.718. Okay. So by solving this, I is equal to I naught into 1 minus 0.378. So then I is equal to I naught into 0.632. So what does it mean? So then it means that we can write this I is equal to 63.2% of I naught. So after seeing this derivation, what we can understand is, when we consider if T is equal to L by R, if T is equal to L by R, the current is, the instantaneous current is 63.2% of I naught. So this is the expression is used for when during the growth of current, during growth of current. So during the growth of, means the plug key is closed, the current is growing, that means the current is increasing the circuit. So how the current is increasing, this is the expression is indicated. Based on this expression, I consider if T is equal to L by R, what happening I value. It means that this, if in the time, during this time, the current is increased by 63.2% of the maximum value. 63 point, it's not increased during this time. How much current is increased? That means instantaneous current is 63.2% of the maximum value. This time is called, what do we call this time? The time constant. Time constant of inductive circuit. Time constant of inductive circuit. So this is the time constant. It means, what is the time constant? This is time constant in which the current increased by 63.2% of its maximum value. What do you mean? How do you define the time constant? Let us listen once again. This is the time t is equal to L by R. During this time, the current is increased by 63.2% of its maximum value. That time is called time constant of inductive circuit during the growth of current. If suppose if the current gets maximum after some time, the plug key is opened, means off condition. When the plug key is open, the current in this inductive circuit also start to decay. Let's see what is the expression, the current is decreasing in this case. Let's see here in this case. So that expression is I is equal to I naught into e power minus R by L into T. This is the expression for during decay of current. So during decay of current, based on this expression, the current in this inductive circuit start to decrease. Here also, if T is equal to L by R, substitute this expression in above equation, then I is equal to I naught into minus R by L into L by R, then I is equal to I naught into e power minus 1, then I is equal to I naught into 1 by E, then I is equal to I naught into, what is the value of E you already mentioned here, that is 2.718. So then I is equal to I naught into, you already mentioned 1 by 2.718 value is 3.78. So then it means that I is equal to 37.8% of I naught. What do you understand here? During this time T is equal to L by R. During this time the current falls down, the current decayed. How much percent the current decayed? 37.8% of its maximum value. 37.8% of its maximum value during this time, that is L by R time. So this time is called the time constant. The time constant during the decay of current for the inductive circuit. So there are two here. During the growth of current, time constant is L by R. During the decay of current, the time constant is L by R was taken. Whereas during the growth of current, during this time, how much current is increased? 63.2% of the current gets increased. Maximum current is increased. During the decay of current, during the same time, that means L by R, how much current fall down, how much current decayed? So 37.8% of the maximum current fall down. Okay. So in the same expression, we can discuss in the same way, we can discuss about the capacitance circuit also. In this capacitance also, the charge is, the capacitor is getting charged continuously. It does not charge instantaneously. It takes some time. When plug key is on, when the plug key is off, the capacitor start to discharge. So the discharge of the capacitor also does not take place instantaneously, does not take place quickly. It takes some time. Charging of the capacitor takes some time. Discharging of the capacitor is also taking some time. The same way we can discuss, let's see that in this case. So in case of capacitance, how the charge is when during the charging. You can see that during charging of capacitor. During charging of capacitor, if the plug key is opened, if the plug key is closed, when the plug key is closed, the capacitor is getting charged. So how the capacitor is getting, we have an expression Q is equal to Q naught into 1 minus E power minus T t by RC, E minus t power RC. Based on this expression, this is also exponential function. The capacitor is getting charged exponentially, does not take place instantaneously. How the current is increased instantaneously in the pure resistance circuit, it is not happening in both these cases. There is some lag, there is some time. So here also, if t is equal to RC, if t is equal to RC, substitute above expression, the Q is equal to Q naught into 1 minus e power minus t by, sorry, in the place of t we need to write RC by RC, then Q is equal to Q naught into 1 minus e power minus 1, then Q is equal to Q naught into 1 minus 1 by E. We already know what is the value of here. The Q is equal to Q naught into 1 minus 1 by 2.718, then Q is equal to Q naught into 1 minus 0.378, then Q is equal to Q naught into 0.632. That means Q is equal to 63.2% of Q naught. Here also we need to understand, if T is equal to RC during this time, what is happening? The charge of the capacitor is increased by, the charge in the capacitor increased by 63.2% of the maximum charge can be held by this capacitor. So this time is called time constant, is called time constant for capacitance circuit. Capacitance circuit. So earlier in case of inductor circuit, what is the time constant we got? L by R. Whereas here for capacitor circuit, T value is RC. During this time, the charge in the capacitor can be increased by 63.2% of the Q naught during the moment the plug key is closed. In the same way, let us discuss about when the plug key is opened. When the plug key is opened. When the plug key is opened, what happening? The capacitor starts to discharge. So means during the discharge of capacitor. During discharge of capacitor. So during the discharge of the capacitor, in what expression, based on what expression the charge in the capacitor gets discharged, means that is Q is equal to Q naught into e power minus t by RC. Here also same method we followed. If T is equal to RC, if T is equal to RC, then Q is equal to Q naught into e power RC divided by RC, then Q is equal to Q naught into e power minus 1, then Q is equal to Q naught into 1 by E, then Q is equal to Q naught into 1 by 2.718 E value is, then Q is equal to Q naught into, that is 0.368, we already discussed here, then Q is equal to 36.8% of Q naught. Okay, what does it mean? During this time constant, that is T is equal to RC, during this time when the plug key is open, the charge in the capacitor getting to discharge. So how much of charge get discharged? 36.8% of the maximum charge. 36.8% of the maximum charge gets discharged during this time T is equal to RC. So this T is equal to RC is called time constant, the time constant for capacitance circuit. So these are the time constant for both inductive circuit as well as and capacitance circuit. Now in this topic we are going to discuss about the mean value of AC current and RMS value of AC current. the mean value of AC current, that means alternating current, or it is also called average value. It is also called average value of AC, alternating current. So it is denoted by IM, suffix in suffix M. In some books they followed IAV, average. Okay. So in this case, we already know the AC current varies sinusoidally. The alternating current varies sinusoidally. Okay. The magnitude as well as direction varies sinusoidally. During the positive pulse, means this is a T by 2, total one pulse means time taken to produce total pulse is capital T, the time period. Means first half pulse produced in T by 2, remaining half pulse produced in during T by 2. So total is capital T. So during the positive pulse, the average current, we can understand the mean current of this positive pulse is 0. We already learned in mathematics how to calculate the mean. So based on that, if you calculate the mean value of all the currents indicated during the positive pulse, that becomes equal to 0. And similarly, during the negative pulse, so there is some value. During the positive pulse, not 0. During the positive pulse, the average value, there is some value. Similarly, during the negative pulse also, the average value of alternating current also can be some value. So if you add all this average value over a complete one cycle, the average current becomes 0. The average current becomes 0. Why? Because the value we got during the positive cycle for average current, the same value we will get during the negative half cycle, but it becomes negative value. If it is a positive value, it becomes during the negative cycle, it is negative value, so that the total value becomes 0. So in this way, we are going to calculate the mean value of AC or average value of AC over half cycle only. Over half cycle, we need to remember this one. Average value of not for one cycle, only for half cycle we are going to calculate here. There is some derivation. So that half average value, that means IM, can be written as, that is, we already know the current is being varied based on the equation I is equal to I naught sine omega t. This is sinusoidal function because the current is varying sinusoidally. We already learned in the oscillations chapter and oscillations chapter, we learned about simple pendulum, simple harmonic motion chapters. In this chapter, we learn about x is equal to a sine omega t. So based on this expression, what we can understand, the displacement of the particle which is in SHM follows this equation, means that follows the sinusoidal functions. Okay, so which is the physical quantity is varying sinusoidally, we adapt the sine function to understand those physical quantities. Similarly, here the current is being varied sinusoidally. So that's why we are representing this alternating current by using the sine function, sinusoidal functions, that is I is equal to I naught sine omega t, whereas I naught is the maximum current. The maximum current, whereas I is instantaneous current. Instantaneous current. So omega is angular frequency. Angular frequency. This omega is equal to 2 pi nu. Nu is the frequency. So generally the frequency value is 50 hertz. Okay, the t is in value of time, instant of time. So why we use the sine function for the representing alternating current? Because the current is being varied sinusoidally. Okay, na? So in first year we discussed about in oscillation chapter the displacement of the particle which is in SHM, simple harmonic motion, is varied as per this equation because sine function is used. Here also the current is being varied according to the sinusoidal functions. So sinusoidal functions is used to understand this physical quantity. Similarly, the EMF is of the alternating EMF is also used. E is equal to E naught of sine omega t. So the EMF is also being varied as per the according to the sinusoidal functions. Okay, so here the I average, I mean can be written as integral of 0 to this start is time to t by 2, integral of 0 to t by 2, that I into dt. So this can be written as integral 0 to t by 2. In the place of I you can write I naught sine omega t, so into dt. By solving this expression we will get the value of Im is equal to, that is 2 by pi into I naught, 2 by pi into I naught. So this 2 by pi value I naught is equal to how much of value is, that is Im is equal to 0.638 of I naught. So this is the 0.638 of I naught. This is the average value of alternating current. Similarly, the mean value of AC, or mean value of AC, the mean value of EMF. The mean value of EMF also can be calculated in the same way. That is EM can be written as 2 by pi times of the maximum EMF. 2 by pi times of the maximum EMF. That's value is the EM is equal to 0.638 of E naught. Okay, it means that the average value during the positive half cycle or a negative half cycle, the value is 2 by pi I naught. During the positive half cycle we calculate. If suppose during the negative half cycle, what is the average value? During negative half cycle, that Im is equal to minus 2 by pi I naught. So this is the value of during positive half cycle. This is the value of during negative half cycle. So the total value, if you add both the values, what we get? We get 0. Then the average value over complete one cycle is 0. We need to understand. So here the mean value of EMF is similarly during the positive half cycle. It is during positive half cycle is EM is equal to 0.638 E naught. Similarly, for during negative half cycle, during negative half cycle, that is EM is equal to minus 2 by pi into E naught. Okay. Similarly, for both the halves, means for one complete cycle, the average value of EMF is equal to 2 by pi E naught plus of minus 2 by pi E naught. So what we get, we cancel each other, that becomes 0. So for one complete cycle, the average EMF is 0. Similarly, for one complete cycle, for one complete cycle, the average current, that is I is equal to Im is equal to 2 by pi I naught plus of minus 2 by pi I naught, but becomes 0. So these are the constants. So for one half cycle, the average current is 2 by pi I naught. During negative half cycle, the average current is minus 2 by pi I naught. For one complete cycle, average current is 0. Similarly, the mean value of EMF for positive half cycle is 2 by pi times of E naught. During negative half cycle, the average EMF is minus 2 by pi of E naught. That for one complete cycle, the average EMF is 0. Similarly, next we are going to discuss about the RMS value of AC.